On August 12, 2026, a shadow will begin moving across the Northern Hemisphere. It will travel over the Arctic, Greenland, Iceland, the Atlantic Ocean, northern Spain, and a small corner of Portugal. As the shadow arrives, daylight will weaken. Temperatures may fall, bright planets and stars may become visible, and the sun will appear to disappear from the sky. For people standing within a narrow path across Earth, the moon will completely cover the sun. Day will briefly become night. This will be the first total solar eclipse visible from mainland Europe since 1999. Much of Europe, northern North America, and Western Africa will experience a partial eclipse. But only observers inside the path of totality will witness the sun's brilliant atmosphere surrounding a completely dark center. The darkness will last only moments, yet those moments will reveal a part of the sun normally hidden by its overwhelming light. The great eclipse of 2026 is approaching. The sun is approximately 400 times wider than the moon, but it is also roughly 400 times farther away from Earth. This remarkable relationship makes the sun and moon appear almost the same size in our sky. During a total solar eclipse, the moon passes directly between Earth and the sun. Its dark central shadow, known as the umbra, falls across a narrow section of Earth. Anyone standing inside this moving shadow can see the moon completely cover the bright surface of the sun. Outside this narrow path, the lighter outer shadow, the penumbra, creates a partial eclipse. The moon's orbit is slightly tilted, so the three worlds do not align perfectly every month. Most new moons pass above or below the sun from our perspective. A total eclipse happens only when the alignment is precise enough for the moon's shadow to reach Earth. On August 12th, that alignment will produce a moving corridor of darkness across part of the Northern Hemisphere. The moon's shadow will touch only a narrow corridor across Earth. The path begins in the far north, crossing parts of northern Russia and the Arctic Ocean. It then moves over Greenland and western Iceland before racing across the Atlantic. Finally, it reaches northern Spain and a small corner of northeastern Portugal near sunset. Locations outside the path, including much of Europe, most of Canada, parts of the northern United States and northwestern Africa, will see only a partial eclipse. Inside the path, the exact experience will depend on location, weather, and distance from the center line. Reykjavik may experience approximately 1 minute of totality. Other locations could receive longer periods of darkness, with the maximum duration reaching approximately 2 minutes and 18 seconds. In Spain, the eclipse will happen close to sunset, creating an unusually dramatic view near the western horizon. But the path is narrow. Traveling only a short distance outside it can mean the difference between a partial eclipse and complete totality.
As the moon moves across the sun, daylight begins to change. Shadows become sharper, the temperature may drop, and the surrounding landscape takes on an unfamiliar color. The remaining sunlight becomes a narrow crescent. Then, moments before totality, the final points of sunlight shine through valleys along the moon's edge. These are known as Bailey's beads. As the last brilliant point remains, it creates the famous diamond ring effect. Then the sun's bright surface disappears. The sky becomes dark, and the sun's outer atmosphere, the corona, appears as a pale, glowing structure surrounding the black silhouette of the moon. The horizon may glow in every direction, while bright planets and stars become visible. Animals may respond as if night has arrived. For approximately 2 minutes, at the best locations, observers will stand inside the moon's shadow. Then sunlight returns from the opposite side, producing another diamond ring. Totality ends almost as suddenly as it began.
A total solar eclipse is more than a spectacular event. It provides scientists with a rare opportunity to study the sun's faint outer atmosphere. The corona is normally hidden by the intense brightness of the sun's visible surface. During totality, the moon acts like a natural shield, allowing the corona's delicate structures to become visible. Scientists can examine how its shape is influenced by the sun's magnetic field. They may also observe glowing prominences, loops of hot plasma extending from the sun's edge. Researchers use ground-based telescopes, specialized cameras, aircraft and high-altitude instruments to collect information during the brief darkness. They can study changes in Earth's upper atmosphere as sunlight suddenly disappears and returns. Eclipse observations also help scientists improve their understanding of space weather. Solar activity can affect satellites, radio communication, navigation systems, and electrical infrastructure on Earth. Totality lasts only a few minutes, so every experiment must be carefully prepared. The Moon's shadow becomes a temporary laboratory moving across the planet. A solar eclipse must be viewed with proper eye protection. During the partial phases, never look directly at the Sun without safe solar viewing equipment. Normal sunglasses are not sufficient, even very dark ones. Use eclipse glasses or handheld solar viewers that comply with the ISO 12312 International Safety Standard. Check them before use. Do not use viewers that are torn, scratched, or damaged. Cameras, binoculars, and telescopes require specialized solar filters securely attached to the front of the equipment. Never look through an optical device while wearing eclipse glasses. Concentrated sunlight can damage the viewer and cause serious eye injury. Only people located inside the path of totality may remove their eclipse glasses when the Sun's bright surface is completely covered. The moment sunlight begins to return, eye protection must be replaced immediately. People outside the path must keep their protection on throughout the entire event. On August 12th, the Moon's shadow will briefly reveal the hidden beauty of our Sun. The darkness will last only minutes, but for those who experience it safely, the memory may last a lifetime. This is the Infinite Archive, where the universe keeps its greatest secrets. Subscribe to the Infinite Archive, new cinematic documentaries every week.